Vega technology. At the center of the Vega launcher's success is a completely Italian technology made by Avion: filament winding. Combining lightness and resistance, this is the technique that enables the production of the solid propellant motors in carbon fiber, a material twice as resistant and 4 times lighter than steel. On a metallic bearing structure, the mandrel, a casing of rubber with special characteristics, also called thermal protection, is first applied, then vulcanized, that is to say, hardened. Subsequently, a filament in carbon fiber and resin is wound onto the rubber casing. After the winding process comes the curing. Then the mandrel is removed and the insulated casing is obtained. More than 2,500 kilometers of filament are needed to produce the first and largest of the 3 stages, the P80. Altogether, over 4,000 kilometers of filament are used for the first 3 stages of the launch vehicle. How the motors work. Once the motor case is filled with propellant, an igniter is inserted into the upper part of the motor, and the nozzle that allows the guidance of the exhaust gases that supply the thrust is inserted into the lower part. The first 3 stages of the Vega launcher, the P80, Zefiro 23 and Zefiro 9, are solid propellant motors and, once ignited, thrust the launcher until the propellant finishes. The 4th stage. The 4th stage, the AVM, uses instead a liquid propellant that enables the motor to be switched off and reignited up to 5 times in order to put the satellites into orbit with an approximation of just a few meters. There are over 15,000 meters of cables in the Vega, and over 400 sensors distributed throughout the launcher measure the vital parameters, temperatures, pressures and acceleration. The AVM, besides being the last motor that finalizes the flight, contains the brain of the launcher. The avionics system, together with flight software, enables the guidance and control of the launcher during its mission.